This is the video for page 419, 29 to 51 odd. Y'all's homework was 30 to 52 even. Alright, so instead of square roots now, we're dealing with fourth roots and fifth roots and cube roots and roots that aren't necessarily just squared. And the way you know is by this number right here, which we call the index. So fourth root means something times itself times itself times itself gives you 16. So 16 is a pretty low number anyway. So something times itself times itself times itself would have to be a pretty low number in order for it to be 16. So let's try 2. So we have 2 times 2 is 4, times 2 is 8, times 2 is 16. So we've got 1, 2, 3, 4 2s. So 2 times 2 times 2 times 2 is 16. So the fourth root of 16 is 2. And you keep that negative out in front of it, so your answer is -2. Okay? Same situation here. What times itself times itself times itself gives you 16? Well, that's 2, we know. However, this time the negative's under the square root. Anytime you multiply two numbers together, if it's two negatives, you get a positive. If it's two positives, you get a positive. So there's no way that you can multiply a number 4 times and get a negative number. So anytime that your index is even and you have a negative under the root, it will be not a real number. We're going to pretend we don't know anything about imaginary numbers yet. So you just say not a real number and you move on. Okay, now notice here we have a negative under the fifth root, but it's okay because your index is odd. So again, something times itself times itself times itself times itself is going to give you 32. It probably needs to be a decently small number, so we'll try 2. So 2 times 2. Now, because it's negative, let's go ahead and make all of our numbers negative and see what happens. So -2 times -2 is +4. So we have 1, 2 of them so far. Times -2, so now we've used 3 of them, is -8. Times -2, so now we've done it 4 times, is -16. I'm sorry, +16, excuse me. And then 16 times -2, so this will be our 5th time, so we're good, is -32. So the 5th root of -32 is just -2. Okay, so now we have an index of 5, and let's just clear up some vocabulary here. So this number here is your index. This number here is your radicand. Sorry if you can hear the lawnmower. They're mowing. The lawn service is mowing my lawn right now. And this number here is your exponent. So when I'm referring to them, make sure you know which one I'm talking about. So when you take a radicand to an exponent and you have you can move the index back and put it underneath your exponent. So what I mean by that, I'm not sure why I wrote 20 there. There we go. What I mean by that is you can take your index and swing it around back and it becomes the denominator of your exponent. And we know that when that happens, your square root or your radical symbol goes away. So when we do that, we know that 20 divided by 5 is 4. So your answer to this would just be x to the 4th. So whenever you whip that index around back and make it the denominator of your exponent, then your radical is going to go away. So you have just x to the 4th will be your answer to 35. Alright, so let's go ahead and do this. But be careful here. What is being raised to the 12th power? Just x. So I'm going to treat this two different ways, with like two different problems. The 6th root of 64 times the 6th root of x to the 12th. That's the easiest way to see it. So with 6th root, it's what times itself times itself times itself times itself times itself gives you 64. So again, let's start rather low to see if we can figure it out. So we're going to say 2 times 2, that's 4. So I've got 1, 2, 2 2's, times 2 is 8. That's my third 2. So 8 times 2, that's my fourth 2, is 16. Times 2, that's my fifth 2, is 32. times 2, that's my sixth 2, is 64, right? And that's what we're looking for, 64. So the sixth root of 64 is just 2. So we took care of that one. Now here, we're going to take our index and bring it back here and make it our denominator. And when I do that, my radical goes away. So you're just left with x to the 12 over 6. We know 12 over 6 is just 2, so you're left with x squared. So your answer is 2x squared. Cody, don't go in there. Alright, so I'm going to split this up again, because again, only the x is being raised to the fourth power. So you've got the square root of 81 times the square root of x to the fourth. We know the square root of 81 is 9. What times itself gives you 81? Here, remember, if there is no number out in front, we know it's a 2. I'm going to take it back and put it as my denominator. When I do that, my radical goes away, and I'm left with x to the 4 halves. And we know 4 halves is just 2, so it becomes x squared, so your answer is 9x squared. Alright, same thing. I'm going to split this up, because again, only the x is being raised to the 8th power. So I've got the 4th root of 256 times the 4th root of x to the 8th. Okay, so for 256, remember, we just found the 4th root of something else. I don't remember what it was. The 4th root of 16, we know that was 2. Okay, so it's probably going to be a higher number than 2. Let's try 4. So we're going to do 4 times 4 is 16. Times 4, that'll be my third 4. 16 times 4 is 64. Times 4, I don't know what 64 times 4 is 256. Okay, so we know we've got 1, 2, 3, 4, so the 4th root of 256 is just 4. So we did that one. Now we're going to take this index and make it our denominator. Remember, when we do that, our radical goes away. So I have x to the 8/4. We know 8/4 is just 2. So this becomes x squared, so your answer is 4x squared. Alright. Now, notice parentheses here, so the entire -8 is being raised to the second power. You can do this a couple different ways. I'll show you both ways. Okay, first off, if I took -8 and I squared it, I would get 64, right? So then I would have the square root of 64 is 8, right? Okay. Now, this is a really bad example because of the negative to show you the other way to do it, so I'm going to wait and I'm not going to show you that way right now. Okay. Now, we've got the cube root of -8 cubed. Well, -8 cubed. Okay, so -8 cubed, sorry about that, is -512. And then we're going to say what times what times what gives me -512. Well, we know it's -8. So your answer would be -8. However, another way to do this is if your index and your exponent end up being the same thing, they actually cancel each other out. And your answer is just -8. Because, remember I just taught you, you can take your index back and make it an exponent. So if I were to take this back and make it the denominator, 3 over 3 is 1, so your answer would be -8 to the first power. Alright, here we have the square root of 4 times the square root of x squared. Okay, well we know the square root of 4 is 2, and I just told you if your index and your exponent match, you can cancel them out. So remember, this is an unassumed, or an assumed 2. So they're the same, so they cancel out. So your answer is actually just 2x. All right, same thing here. Index and exponent the same, so your answer is just x. Or you could look at it this way. X cubed is x times x times x. In order to be able to bring it out front, you need 3 of them. So 1, 2, 3 brings 1 out front, and nothing is left on the inside. Look away. Okay, here we have the square root of x minus 5. So remember, square root is an assumed 2 there. Since the index and your exponent are the same, you can just cancel them out, and then your answer is just x minus 5. Don't make it more complicated than it is. That's it. You guys have a great night, and I'll see you tomorrow.